Hello everyone and welcome to week 3. Chapter 31 is a pretty beefy chapter. We're going to divide that into week 3 and week 4. So I've divided the chapter in half. The good news for you is there's quite a bit of extra information in there. So really pay attention to the weekly instructions because there are pages that you're going to be able to skip in the book, and I have those in the PowerPoint. So what I want to start talking about for this lecture is the processing domains. So this is just basically a review of digitizing the image. So the data comes in, it's scanned, it's sampled, and then there's a quantization. So basically what is happening is we're talking about what's happening during this digitizing of the image and as we get ready to display it on the monitor. How does it look? Here are some terms that you need to know, so make sure that you know these for this week. You can go through those and find those. Please do the workbook. There are great questions. I'm going to use those for your assignment. And I did the workbook without looking up the answers myself and found them in the chapter. So the answers can be found in the chapter. So what are image domains? So there are 3 different image domains. It begins with the spatial domain. This is the one that we are most familiar with, and it ends with the matrix. And so we think about when we take an X-ray, where does that end up on the matrix? The next one that we are also familiar with is the intensity domain, and this is as the X-rays go through the patient, they're recording the gray scale that shows up. So, and then that generates a histogram, which shows up on your control panel, and you see the histogram all the time, but you just really don't pay that much attention to it. So the intensity domain will store the gray levels. And then frequency domain is the one we're least familiar with, and this sorts the image based on its size, and it shows up as a little frequency graph, which we are not going to spend as much time on. So let's talk about spatial domain, or basically the matrix. So this relates to the specific location of each pixel inside the matrix. So there are 3 different processing operations that you can do under what's called the spatial domain processing operation. So point processing is basically when it says specific algorithm, that it performs a specific algorithm pixel by pixel or point by point. It's making a specific change to each individual pixel by pixel, point by point. So when you do subtraction, that's a good example of a point processing operation that happens under the spatial domain. Again, you just need to know when I say point processing, which domain is that happening under. Area processing is going to be a little bit bigger. It's going to include a group of pixels. So whenever you zoom or magnify, you're not zooming or magnifying the whole image. Usually you're focusing on just a section. So that's an area processing function that happens under the spatial domain. So it's looking at an area of pixels within the matrix. Global processing is going to execute a function across the entire image. So basically it's going to include all of the pixels. So when you flip the image from right to left, that's a good example of global processing that happens under the spatial domain. Intensity domain is basically the generation of a histogram. We're going to talk a lot more about histogram next semester, so don't get too worried about it, but we're just going to start talking about it now. So histogram or intensity domain relates to the specific pixel values or gray levels that are stored in each pixel, and it doesn't matter where they're located. So a construction of a histogram is the radiation intensity as it goes through the patient graphed on a chart. And we're going to talk about, like I said, histogram later. And then an anatomical lookup table is a good example or a sample good image that's in the system that compares with your image. So when you take an X-ray and you select AP abdomen or PA hand, there's a good PA hand or AP abdomen that has the pixel values already plotted in a lookup table. So when your image pops up, it's comparing it to what's in the system. And then when you window and level, you're changing the brightness and the contrast. You're basically changing the intensity domain functions. And then frequency domain is as the frequency comes in, it's measuring the size of the object regardless of its location. So when you think about edge enhancement or smoothing, those are good examples of things that are changed. This Fourier math transform that we're talking about, an inverse Fourier transform, is basically whenever you want to convert from a spatial domain to a frequency domain. Physicists and engineers prefer to look at the image. They prefer to look at the image and see what's happening at this. This tells them a lot about what's going on with the image. It doesn't tell us anything, okay? But that's how physicists and engineers look at it. So if they see this or they see this, they want it changed. They want to change into the frequency domain so that they can see what's going on with the system. That's basically what that means. So what does all this really mean? Basically, there are 3 approaches to sorting or processing any digital image. So you can sort it by its location, which is in the spatial domain, and that you can change the mag or zoom, and that affects the distortion of the image. You can sort the image based on its pixel intensity, so the grayness levels that are in there. So brightness and contrast are good examples there. Or you can sort the object based on its size, which is the frequency distribution. So that can actually affect the detail and distortion. So the basic thing to understand is that the sorting process or this approach is tied to different features when you manipulate the final displayed image. And so like I said, as you can see, these are related to what you already know: brightness, contrast, resolution, and distortion. So that's where we're going to end with the domains, and please let me know if you have any questions.